Okay, Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. Assalamu alaikum, peace be with you, and the blessings of God. A-level live lesson, it's year 1 maths, and we are looking just to warm your brains up with a little spot the difference. Picture quality is not good. I probably should have picked a better image quality to put on there, but hopefully you can see there is a difference somewhere. Let's see if I can just get a better quality picture, maybe by going to the larger version of it. That looks a bit, oh, that's much better. Didn't want to do that. Let's zoom out. So is there a difference? Where is the difference? Have a closer look. Okay, if you're confident enough, if you're brave enough, just type into the chat window if you have spotted a difference, if you're that quick. I haven't given you that much time, but if you're quick, if you've been quick enough, just type in whereabouts the difference is. Maybe you're off to a slow start, that's fine. We'll just give you one of them. Is going to be this set of 3 pegs here, and if you compare that with the 3 pegs here, you should be able to spot a difference. We got something missing here, and there was another difference I noticed around one of these pictures here, but if you haven't noticed it, no problem. And there's also something around this area here. If you look carefully, type it as soon as you can see it. No, maybe we'll save that for another time. So let's look at disproof by counter example. So here it's quite easy. You're not looking to prove anything. You don't have to do any laborious maths like yesterday. It was quite long. If you look at the number of lines of maths you had to write to prove something, here there's no such hard work. You just need to find a counter example. It's called disproof by counter example. It means find an example where the statement isn't true, and because proving a statement, you have to prove it for every single possibility. Well, when you're trying to disprove a statement, it's actually quite easy, because all you have to do is find one example when it's not true, and that's enough to break the statement. That's enough to break the statement, to say it's not true, because you found one case where it's not true, and a true statement has to be true all the time. So let's take a look at today's statement. And hopefully you've got a copy of the book to work through along with these lessons. If not, you can order it from Amazon. Okay, Bismillah, in the name of God. Let's just go through this. Disprove the following statement. So the method of disproving hasn't been mentioned, it's just open, but the easiest method is just to find an example where it doesn't work. So here's what you have to try to disprove, or ask yourself, does it work? For any pair of integers, x and y, integers, whole number, and we've got a pair of them. Now it doesn't say x and y are the same, it doesn't say they're different. When you use different letters, you're just allowing for the fact that they're different. They could be different. If x is bigger than y, so if you've got a pair of numbers, whole numbers, and one of them is bigger than the other number, is it true that x squared, the first one squared, plus the number again, itself, x, would be bigger than y squared plus y, i.e. the second number squared plus y. So here the statement is saying it's true, and you just have to find one example of when it's not true to be able to disprove the statement. And it can take a couple of attempts, so similar to when you were looking at the spot the difference. Sometimes it takes a couple of attempts to look at which part of the picture is the difference. Maybe you're thinking it's the bed, and then you think no, actually there's nothing different there, and then you go to another part of the picture. So similarly with this, you just have to try a couple of examples, and don't be afraid of having to try a couple of times. So I always try to go with one's a nice number to go with, because it can break a lot of the expected rules. So for example, a lot of people think that if you times by a number you'll get a bigger answer, but well, if you take 5 and times it by 1, you don't get a bigger answer. So 1 is a nice number to try and test with, and also you could try a negative number or 0. They're good numbers to try and really put a statement to the test. So let's go with x is 1, then well, we need another number because we have to have a pair of numbers. So let's go with y equals 2. Now it says if x is bigger than y, that's not going to work, so I could do it the other way around. I could have, let's go with x as 2 and y is 1. Then x squared plus x, let's work that bit out. So that's going to be 2 squared plus the 2 again. So that works out to be 6. Just make the writing a bit clearer by using a thicker brush size. And then we do the same with this side. So we've got y squared, that's 1 squared, plus 1. And that works out to be 2. And we see that 6 is bigger than 2, which is what the statement is saying. The 6 is bigger than 2, the x squared plus x is bigger than the y squared plus y. So that's an example of the statement working. We were hoping for an example where it's not working, and that's our job done. But not to worry, you just, like I said, have to make a couple of attempts. So just keep going. Let's go with, let's say x is minus. Let's bring a minus in there, but I don't think changing it from 2 to minus 2 will do much. Let's go with 1 and minus 2. So it said integers, whole number, so minus 2 is a whole number. And x is 1, that's a whole number. So let's try that again. So I'm just going to make this a bit bigger. So let's try this. And the first part, x squared plus x, that's 1 squared plus 1. And that works out to be 2. And just to check, is the first part true? Is x bigger than y? Yes, 1 is bigger than minus 2. So we're good to go and try the y squared bit now. So minus 2 squared, well that's 4, plus y, that's plus minus 2. And a plus and a minus makes a minus. 4 minus 2 makes 2. So I can just say that this bit would be equal to 2. And I probably just want to change my color here just to make sure that you don't get too confused. I'll put a line down the middle just so that you know that they're two different sections. So we've got 2 on the left and we've got 2 on the right, and that's enough to disprove the statement, because the statement didn't say greater than or equal to. The statement said x has to be bigger than y, and as long as that's true, which it is, 1 is bigger than minus 2, then your x squared plus x bit will be definitely bigger. This is a bigger than sign. It's not a bigger than or equal, it's bigger than the y squared plus y. And here we put in two numbers, they're both whole numbers, x is bigger than y, but we didn't get the x squared plus x was bigger than the y squared plus y. So we can say, using that example, the statement is false, it is not true. And that's it. That's disproof by just finding one example that doesn't fit the statement. Okay, you'll be pleased to know that that's all the theory done for that chapter of proof, and now it's really your turn to just work through the questions. You've got at the end of every chapter, and sometimes during the chapter, you've got questions to work through. And the target is really to get through the questions, get through the chapter. One chapter shouldn't take you more than 2 weeks, and we are in our second week now, so I'll let you work through those questions. Tomorrow we'll be starting the next chapter, but by this time, by Monday evening or over the weekend, you should really aim to get these questions done, and that way next week you can dedicate to the next chapter. Okay, fantastic. Short lesson today. Apologies that we started a bit late, internet problems, so I had to restart my laptop. And thanks for joining me. Next time we'll have a lesson tomorrow, 9 p.m. inshallah, if God wills. See you then. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be with you and the blessings of God.